Hey guys, welcome back to the channel. In this session, we are going to continue with the recurrences and going to look at how we can create a recurrence relation from a code. I recommend looking at the introduction to recurrences, which is the previous video I recorded on this subject before going into this session. So I'm going to continue with the previous code example which we discussed in our previous lecture, and we are going to create a recurrence out of this code. So just to do a quick recap, this is a recursive function where we are passing an integer value to this function. If the value of n is 0, we return, otherwise we print the value of n, and then we call this function again with the value 1 less than n, and that's how it becomes a recursive function. So for a value of n, this function will be called n plus 1 times. Why it will be called n plus 1 times? You can refer to the previous lecture on introduction to recurrences, where I have explained in detail why it will be called n plus 1 times. So now let's see, if we see this line number 10, this, what would be the time complexity of this line? This line will be called once and the time complexity is constant. So we can say this line's time complexity is O1. Now this is a recursive call. In a recurrence, a recursive call is denoted by, let's say, T, and how the value of n is changing. The value of n is 1 less than the current value. So we call it P n minus 1. So then how much work we are doing in this function? We are doing a work of Pn minus 1 plus O1. So if we want to write a recurrence for this function, this will be T n minus 1 plus that's it. Pretty easy, right? Okay, let's take another example. So let's say, as we discussed in our previous lecture, that why do we need recursive functions? We generally need recursive functions where we want to solve a problem and we want to divide the main problem into smaller problems and then find a solution to the smaller problems. So let's say what we want to do is we want to find a value in an array using a recursive call. In a trivial scenario, finding a value in an array could be done by a for loop in an iterative way, where we can have a for loop and we iterate the array one by one and compare the values, and as soon as we find the value, we return. But let's say we want to do the same thing using a recursive call. So let's see. We say recursive array search, which takes an array. After that, it takes the size of array, and then it takes what do we want to find, right? This is our function, and it is going to return the index of the value if we find the value, otherwise it is going to return -1. Okay, so if we see at a high level, what we want to do is we are going to call this same function, but every time with a array size 1 less. What else is needed? If size becomes 0, this means we haven't found the value in the array. So we are going to return -1. And if array size -1 is equal to valid to be found, then we will return the current index, which is size -1. Because size is, let's say, 5, but the array is 0 based. So we are going to return 1 less. And otherwise, we are going to call this function and return what it returns. I think this is a recursive function to find a value in an array. Now let's call it. So I am going to create a array which is comma 2 comma 3 comma 4 comma 5 comma 6. So the size is 6, and recursive array size is 6. And what do we want to find? Let's say we want to find 5. If we are going to print idx value not found, if the value return is -1, we will say value not found. Otherwise, we will say value found at index idx. Okay, fine. Let's run it. Okay, I'm going to comment the previous code. So it said value was found at index 4, which is 0, 1, 2, 3, 4, right? Okay, but this example is not to search a value. This example is how we can write a recurrence for this function. Okay, so let's say generally in recurrences we don't count the conditional code. Okay, but let's say we want to do that for completeness. So we will say this if is constant time, this if is constant time, and this is a recursive call which is reducing the problem size by 1. So same like previous. Okay, so then the total time is tn minus 1 plus o1 plus O1, or we can say plus some constant. So that's how a recurrence for this code can be created. Let's take one more example, which is a little more complex, to give you a broader picture of how we can create recurrences out of code. So let's take an example of merge sort. I'm not going to write the full code. I'm just going to write the basic high level framework of merge sort and how it works. So generally, merge sort signature is, let's say, I say void merge sort, which takes a left side of the array and right side of the array, and let's say an array. I would say have a look at the proper code of merge sort for a better understanding. Now, if left is greater than equal to 0, which is the ending condition, we return. Generally, the code is something like this. And then what it does is it creates a midpoint of the array. So midpoint of the array would be right minus left, right? Something like that. And then it calls the same function twice. One for left to mid, and then from mid plus 1 to right. And then later on, it actually merges the sorted subproblems. So it says merge left, mid, right. Okay. It's something like that. Okay. So how much work it is being done? Let's say we say this is doing O1. This is doing 1. This is a recursive call, right? And this is dividing the whole array in half, which is going from left to mid, right? So if there are 10 elements, it is going from left to, which is 0 to 5. And the second call is going from 6 to 10. So this means, what is the recursive call look like? N upon 2, right? The problem is divided in half. If we take the reference of the previous example where the problem was reduced by 1, here the problem is being reduced by half, and same for right. Okay. And what is this line doing? This is running, for every time we run a merge sort on the problem size. So let's say what it does is this is going to merge n upon 2 plus n upon 2 elements, which is n, right? So this line is going to run n times every time. So what is the recurrence relation looks like? T n upon 2 plus T n upon 2 plus O n, right? And plus O n and then some constant, right? So if we ignore the constant, we come up with this, or we can say, let's say some constant, something like that. Generally, these smaller constants are ignored in a recurrence. So this becomes so this is a recurrence for the merge sort. I hope these few examples gave you a very good understanding of how you can create a recurrence relation out of your code which you write. This is a very fundamental thing and very important to learn, because in a real scenario for a developer, when they write code, they need to know how much time that code is going to take. In our next lecture, we are going to solve this recurrence to find out how much exact time this code is going to take. There are different ways to solve the recurrences. One is master method, one is tree method, and the third is substitution method. We are going to look into detail of all these methods, how they solve recurrences, and we are going to look at some of the simple to more complicated examples of solving these recurrences to find time complexity of a certain code. So for now, this is all for this lecture. Thanks for watching, and I am going to see you in our next lecture on recurrences. Thank you very much, and bye for now.